Lot 2, 166 has been printed. $167, so I want to stop here. One count is 167. 35. Let's do it in a different tab. TDB analysis. Break main.cpp 35. Or list main.cpp 37. Okay. Condition 1 count equals. Oh, no, I forgot it. I forgot it. 167. 167. Run. Okay. Now, step. Oh, debug is off. So here it fails. I was going to step into this, but as you can see, we have a lot of debug output. Let me look at the debug output first, see if I can find a clue. Pipeline, randomize the pipeline. That means that we randomize the first stage which is a shader model. So we randomize the shader model, which means we are going to randomize its declarations. It means that shader resource is randomized. It's not really printing what it's doing. It's just which function is. I mean, it prints what function is being called, but not really the result of it. Okay, well, I have mark you a slot. I believe the first stage has 4 declarations. I guess I can see that from here. 1, 2, 3, 4, and then the next stage. Yeah, and then the one after that. 2. Yep. Actually 3. There is a previous stage. I need more debug output too. Hello, Nami-kun. Let's look at what happened in the last case. So in the last case we have I don't know how many. I mean, I'm sorry. I'm just going to add more debug output. Things that I need to know are at least how many declarations it wants to create. Yeah, let's start there. Quit. Why the hell would I have 2 of those? Declarations randomize in pipeline layout.h. Whoops. That's pipeline. Yep. Yeah, set index binding slots with an S. Keeps track of which are already being used. The owner, set number of declarations. I think I want to do that as well. Just print. I'm just going to print, I think, everything. I mean, yeah, every function. And I don't have to step through it, right? Oh, this is shader module. Okay, this is constructing declarations. Then we move it, and then we call this again, so we see that as well. So I should go to the constructor of declaration to pick up the debug output. It's this one. That's not interesting. Magic number also not. Owner, just copy it. Set index binding slot. That is doing something, yeah. It's definitely interesting. Nevertheless, you have to print that we entered it, entering. Yeah. I want, of course, to know when this out of range happens, and I cannot jump to it. So maybe I should save this on ctext again. Now I can jump to it. Out of range. No, I might as well do it like this. Return not out of range. If well, let's negate it. Negate this thing. Now I believe that this constructor also calls init. Let's have a look. That's this constructor that just calls init. When I said I need more debug output, I meant I need more debug output. Can never have too much debug output. I think I'm find myself typing this so often that I think I'm going to make a special macro. I have dout entering, which is already special macro to print entering in front of it. But I'm starting to feel that I should have one that, especially the entering. I mean, entering just basically is always the one that prints this. And then any debug that happens after that, it's trivially the same object. So they usually don't have that. Maybe it should just change entering so that it always appends this pointer. But that would only work when it has a this pointer, which is very often the case. But what if it doesn't have the this pointer? What if I just use it in a normal function? Dout entering. Can it be detected that I do or do not have a this pointer? I could do an if const expression maybe, and then something that's the feeling that this is not working. Anyway, I won't do that now because it would mean a million lines of code that would need to be changed. Yeah. Would be nice if it even printed it should detect the name of the function printed like this. And then the only thing I should have to provide are the arguments. That would be nice. It's a standard thing to print a trace of a function. I have to think about it. Anyway, all the way here, every slot is bit is reset, and then we call randomize. Okay, yeah, well, randomize probably here. Now, what debug output do we know we need here? I want to see mark unused is being called, I guess, which is already printed. Print a slot, which is a bit set, we saw that. And then we have available slots, unused set index binding slots. I want to know the available bits. Yeah, let me just print it here. Debug. available bits is available bits. And then if there's nothing set, then you throw the exception. Okay, I think that's a lot of debug out. I mean, in a happy voice. Let's see. That's a constructor of was it a constructor? Or was it more than a constructor? So the constructor calls init, and then I did init, right? I did init and I did randomize. I don't know. So then we have left, and init is called here again. So we should still do a randomize. I think this constructor here calls randomize as well. So do the randomize of this object, and then we're done. To the constructor of that object, a shader resource, randomize, it's being called from that constructor. Okay, let's show that we are actually constructing it as well. The out entering dc debug, comma a shader resource constructor with an owner and some random number generator and the vector index and the this pointer. Pointing, toing, yep, and then the randomize. And nobody knows what happened. I think I pressed F7. Let's press F8. Now we get here, nobody knows why. I wanted to go to randomize. Here's randomize. See, this is already printed. Declaration. Previous state using slot. So we find out it's being printed, that it's being called, and what is returned as well. And then if there is a previous shot, if there is a previous state that using this slot, then we just copy it. And otherwise, you can randomize on the descriptor count. I think copy from is printing that it is being called, and also printing what is being copied. That's good. And the randomize of the descriptor count. Descriptor count is descriptor count, which has a randomize that prints it, that it is being called. Now it doesn't really matter what the value is even. I could keep disable descriptor count set to 1. Let's see. and descriptor count, randomize, and then the base class randomize. Yeah, I need to know what happens there. That is the base class of a shader resource, which contains a variable m value. Which is being set here. A shader resource index, it's not a bit set, it's a vector index. Okay, I'm printing, I'll re-enter it. I think I'll just want to have, I just want to know what begin and end is. Get sorted begin. Yeah, there we have the stuff that I need to know, unfortunately. Very annoying. Returning. Okay, so let's make it a little bit more clear. What is what? I cannot remember that, I think. Okay, yeah. I'll just use and begin, I think. Well, maybe I should use it like this. I don't know what that returns. I think that returns a character. Yeah, returns an int 8. That wouldn't print very nicely. Cast that to an int. That only works in that case. Yeah. Okay. It's a C cast. So it's more like a reinterpret cast, but it's kind of I should have used static cast anyway, yeah. So, but I was lazy, and it's you know, you over time you grow a habit, and if I cast as a character to an integer just for printing to an O stream, I use a C cast. I mean, don't ask why. It's just what I do. I think the feeling is that this is outside the real code. You know, it's just debug code. So I don't want to spend many characters making things seemingly more unreadable. Also, casts jump out. You know, every time when you see a cast, you have to ask yourself, why? Why is this cast necessary? Because casts are evil. Now, C casts are way more evil than, of course, than the C++ casts like const cast and static cast. But therefore, I never use them. So then, now I gave them more or less a new meaning. That if I use a C cast, I mean the opposite. Namely, it is so unimportant what is happening here that I don't even need to use C cast anymore. That's basically the thing, you know, because it's debug code, and it's just even if the casts would go wrong, C casts are evil in the sense that things are more likely to go wrong than with C++ cast. So if I use a C cast, it tells me like even if it goes wrong, I don't care, something like that. So now it signifies that how unimportant it is. I think I added all the debug output here that I could possibly add. Yeah. And I didn't even make a mistake, or typo rather. So now we run this again. We get a shitload of output. And I get, holy shit. So after 166, that was the last pipeline that succeeded. We start to generate a new one. Well, we begin with a lot of resets. I would have expected to see pipeline reset first, but no, pipeline randomize. Okay, so we begin with a lot of resets and destructions and everything, and then we call pipeline randomize. And then all of this is happening, all the debug output that we just added. And then it fails. And the reason it fails is because there are nothing is left. No available bits are left. Yep, I'm afraid I'm gonna go over all of this output. I'll just have to. Pipeline randomize. That calls state randomize. Now I know that the first state succeeds because it's printing that. I mean, at the moment it throws. it prints failed declarations as a declaration that it was working on at that moment. And then the rethrows, which then prints the pipeline as it was generated so far. So as you can see, we have one stage with 4 declarations. Then we have the second stage with 2 declarations. And then we have the final stage, which is empty because I was still generating it. Well, I have the feeling that it doesn't make much sense to go over or through all the debug output of the first 2 stages. But to get a feel of how it works when it works, maybe I'll have a look at it. So we begin at the top and then hopefully quickly go to the last stage. Shader module randomize declarations, randomize set index binding slots allow all. Used set index binding slots is now 0, meaning that nothing is used. Going to generate 4 declarations. That was correct. Set number of declarations is 4. Set the current declaration vector to that. Set index binding slot, so that is the constructor. With this as owner. What is that? Owner highlights. Nobody knows. Well, that's really weird. That is really weird. It must be a declaration. I guess this is a part of the part of the construction of the declaration. So I'm passing at this pointer to an incomplete object, which gets constructed later on. Yeah, here. So this is the initializer list of the declaration, and then this is the actual body of the declaration constructor. So hopefully we're not doing anything with this pointer except storing it. Okay, so we get entering set index binding slot init. Set index binding slot randomize available bits. Now I have 9 bits available. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, randomly picking bit 7. Slot as bit is now, and that is bit 7. 1, 2, 3, 4, 5, 6, 7. Looks like bit 8 to me. Well, I should count it at 0, I guess. 0, 1, 2, 3, 4, 5, 6, 7. Okay, I like that. Entering shader module. So the maximum value, possible value is, by the way, this is a 9. So 8 is the maximum value, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, of course, I just counted those were 9. Entering shader marked used, shader module mark used slot with the same bit set. Descriptor count reset, well, whatever. And shader resource is constructed now. Next. Call randomize on it. Previous stage using slot. There is none. So yeah, the shader resource, if you want to randomize shader resource, that's only allowed when the set index binding slot, which comes before that in the initializer list, wasn't already used by a previous stage. Well, this is the first stage, so yeah, it's not used. And now we actually randomize it. And that's 2 calls. which causes a call to get sorted begin. So the minimum value is 0 and the maximum value is 1. The reason it is the maximum value is 1 is because apparently I thought we were going to generate four declarations. Oh, it's 1 past the end, sorry. So end returns 1 past the end, so 1 is not even allowed anymore. So the maximum value is 0. So there's just 1 0. And that's what it also says. Setting m value to 0 because that's the only possible value. And the reason is that we are going to generate the 4 declarations, and they must be in order. So the only possible way is to use 0 for the first one, and then 1 for the next one, and 2 for the third one, and 3 for the fourth one. Of course, it must be different as well. Declaration, then we call the constructor of the declaration, which says out of range returns false. Because well, that's what you just did. It's just checking that 0 that we just generated falls in the range that we already knew that what it was. The same calls 0 for begin and 1 for end. That index binding slot constructor. Kind of lost. Where's this being called from? Oh, it's again something with an owner that is created later. It's again a declaration. What? It's a next declaration. Oh, like that. Okay, yeah. Could have done a little bit. Wait a minute. Set index binding slot. Did we do? Yeah. We begin again. Maybe I should print something here like construction of declaration begins, because it's very, like I said, so this is the initializer list of that declaration, this is the body of the declaration. And now we begin again with the initializer list of the next declaration. In total we have 4 declarations. Let me highlight this so I can see the beginning. Okay, then the next one says that the available bits are now this, because yeah, that one was used. Randomly picking bit 2. And there's basically nothing that goes wrong, so I think I can start to scroll down a little bit faster. It just picks 0, 1, 2. And then we have Okay, so here it says the previous declaration. That would be, well, the previous declaration. With shader resource, unit from buffer 0. That is the 0 that we just had no choice to pick. And therefore we return 1. And that 1 is being returned from the begin value. Yeah, so because the previous declaration used 0, then now we cannot use 0, and we have to use 1. That's 1 more than the previous value. Kind of funny, I had like 6 viewers, then I showed how much debug output I have to wait through, and everyone left, except for one. And now I'm going through it, and I have again more viewers, because they don't know how many pages of debug output will follow. No, I'm just kidding, because already I'm gonna go through it pretty fast at some point. Just need to get a feel of it. Okay, so the end is 2, which is just 1 more than the 1, and not more than that, because we have 4 declarations in total. And then again, setting it to 1, because it's the only possible value. And then we get to the body of the declaration constructor. Out of range is again false, because of the exact same reasons. And then we get the next declaration, that's declaration number 3. And now we have only, well, we have 2 that we cannot pick. Randomly picking bit 2. Well, that's not really bit 2 anymore, it's the second bit that is set. And not even that. It's the third bit that's being set. So it's a 1, 2, 3. Yeah, for the set bits 1, 2, 3, and therefore we pick that one. So I should change this into something like randomly picking the third set bit from the right. And then this is again returning 1 more than the previous value. And then the end is set to 1 more than that. And then again there's only 1 possible value. And then we construct a declaration, because I mean, as follows. That's still the case. That's still 3, so it's not out of range. Sorry. No. Okay. And then the final, fourth declaration. Nick, 28 years in C++ and a little over 2 years in Vulkan. Hey Isas, yeah, we're working together, man, side by side. With a big distance, because I have so many monitors that there is no room left and right of me. But, no. I'm rambling. Oh, thanks. Okay, initialize a list of the fourth declaration. That means 3 have already been used. It picks the fifth one, 1, 2, 3, 4, 5. It means we have 1, 2, 3, 4, 5, 6 zeros. Yep. Now the value must be 3 and the end is 4. Which means that's not out of range. It's being moved to declaration. Now we get the second stage. The second stage is saying we are generate 2 declarations. It is allowed again to use any slots. It picks this one. And then it notes that has already been used before. Therefore, it copies the values and it copies vector index is 0, which is uniform buffer 0, right? Let me highlight this and find it back. BB730, which is not the one. Nope, it's this one, BB7A8. BB7A8, okay. Oh, yeah, well, I'll just believe it, I guess. Okay, so this one is out of range. Why is it out of range? Entering shader module get sorted begin vi is 0. Returning 0 because vi is 0. So from our perspective, it could use uniform buffer 0 because this is the first declaration in this stage. Get sorted end. Return 3. That would be because vi equals 1. No, wait. vi equals 0. Sorry, number of declarations is 2. So we get end, yeah, I get end is 4 minus 2 minus 1 is 3 plus 0 is 3. And then it says return true because in value 3 is larger or equal than the end 3. Okay, and why was in value 3? It's not printing that. Why is m value 3? Why the hell is it not printing that? I think that the only thing I understand here is that maybe the copy from copied the value from that previous descriptor. Sorry, that previous declaration. And then that previous declaration should have used 3, which actually is the case because it was the last one. So this one is the one that we copy from, which happens to be the last declaration. So we have somewhere we have blah 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 because it's the only possible value. Where is that? Here. Setting in value to 3 because it's the only possible value, and that it's doing that for this declaration. I should have printed that. Okay, so I have copy from. That's the first copy from, so that should be easy to find back. I think I'm going to redo it and then print that what the value is. Yeah, okay. Yeah, all VI is not even changed. Okay, go back to not print some value equals 3. which is out of range because the only allowed value is well, the only allowed values are 0, 1 or 2, because 3 is reserved for the second declaration, because we are going to generate 2 declarations, as it says here. So one declaration is going to follow this one. The largest possible value is 3, so we cannot use 3 for the first declaration. Therefore, it is rejecting it. It is out of range because 3 is larger or equal than 3. And then what happens? And then we generate a new slot. And we disallow ourselves to use the one that we picked before. And the one that we picked before was, I think, this one, yeah, with 6 zeros behind it. So yeah, that's no longer possible. Randomly picking 7, now that's 0, 1, 2, 3, 4, 5, 6, 7. So that would be 1, 2, 3, 8 zeros, yep. And that is not being used before, so we can just use it. This is the first declaration, so the beginning is still 0 and the end is still 3. And now we will just randomly generate a value. We generate 2. Then of course out of range is false, because we just randomly generated correctly. By picking 2, by the way, we force ourselves to use 3 for the next one. Okay, set index binding slot, init, randomize available bits. Now this one is gone too. Randomly picking bit 5. Randomize declaration previous stage using slot. It's apparently not being used before. Wait, it is. Oh no, it's nonsense, sorry. This is just the first declaration of the current stage. So that one had 3 and the end is of course 5, so there's only one possible value, 3, for this declaration. And we return 3. And it's again 4, yeah, just to check for the out of range. It's not out of range. Get current declaration vector, set current declaration vector. Then we get the last stage, randomize. Okay, so allow all use set index binding slots is now that. Going to generate 4 declarations. Randomly picking bit 5. Entering that randomize declaration previous, that was already being used. So we copy it, and the value is 3. That is out of range because the only possible value is 0 when we have 4 declarations to go. Therefore, we decline this one. Okay, before I go on, let me look at what I think it should happen, at least for the first one. So we have at the moment two stages with these declarations, and we can only use uniform buffer 0. And this is texture 1, texture 0, texture 1, texture 0, uniform buffer 1. So the only thing it possibly could use was, well, slot, a previously used slot 2.0, 2.1. That would be possible. Or it can pick one that wasn't used before, of course. I don't know what's happening. Going to happen. Let's see, out of range, unfinished, 2, because 3 is larger than or equal 1. Yeah, it must be 0. So that one is not allowed. Now note that this, I said 2.1, right? So this is 2.2, so that's 2.1. That one is allowed. The rest is not allowed. If it is being used, I don't know. So now we pick this one. So if that was already used, then we're going to fail again. Previous use slot, but it was not used. Okay, so we can just use it. And then we generate 0 as the only possible value. And range out of range is not out of range, obviously. And then you have the next one. Now this one must use 1, so now we are here. This one must use 1, and 1 is uniform buffer 1. So now it could use, theoretically, 0.2. That's the only possibility. Or a free slot. It picks this one, which is 0, 0, 0.1, 0.2, 1.0. So that's going to be rejected, I think. Or is it not used? Unfinished. It is used. Value is 2. That is not that it cannot be done. So it's out of range. True. So we're rejecting that one as well. Yep. And then we try again. Randomly picking bit 3. Which is also used, so we reject that as well. Out of range returns true. So we generate another one, reject it as well, we generate another one. Randomly picking bit 3, 0, 1, 2, 3. So okay, and then we get that one, which is also used, so we reject that as well. What? 0? Okay, so that's rejected as well because 0 is less than the beginning value. And then we get rejected as well. It's still, why do we keep picking bit 3? Pick 2, pick 2. Okay, and continued, also used, also rejected, out of range because 2 is larger than or equal to 2. Wait. Yeah. Oof, where are we? Previous stage, inner randomize, available bits, picking 1, so it's still not picking the one that it could be picking. But this one wasn't used before, so you can pick it. Seemingly we can pick it. So out of range is false, and we have one more declaration. Now there's only 2 bits left, and we have 2 more declarations to go. I see what is going wrong. I see what is going wrong. Yeah. Okay. Let me finish watching the debug output anyway. Yep. Okay, now let me let it sink in. I have to treat this special. I could be lazy and just treat both special, but it would slightly slow down stuff. Is there no way to detect this afterwards? So I'm calling this. No, I have to call get sorted end again. I'm not sure where's this being called from. So we turn true, and then maybe I can get this value again. Maybe. Not likely. Arg. Now what? Okay. If too large is set, then I need to remember the value of the slot. And what is that? I think the set index binding slot. Current set index binding slots. Declaration, no, as bit, just a bit. So the slot as bit. Set in the binding slot as bit. Okay, so slot as bit type is a bit set, and I call reset so that all the bits are 0. And then when it gets rejected because it's out of range, and well, because it was too large, I add the current bit that just was rejected to my rejected slots. Let me see if that compiles. That compiles, and then of course we lost where I was. No, and yeah, we're back. Okay. And then what I have to do is undo the rejection at the end when we find one, because they got rejected only temporarily because they were too large. But the next declaration, they should be allowed again, because then they are not, maybe not too large anymore. So here I have to undo the rejection of the rejected slots. That means I think I have to add them back to the available slots, right? Where was that? Where's that hiding? The available slots. I think in the shader module, or I don't know. I just know the name. Available slots. Available slots sits indeed in the shader module. See, I can do mark unused. I should call mark unused, which I renamed to a single slot, but release slots. Do I need to release slots as well? Maybe. If it was rejected, then we are definitely not the owner. No, I can just call this. See the current declaration. Would be a bit too ugly maybe, but horribly ugly. This is like a hack if I do this. I'm doing it anyway. I need the shader model, and I'm going to use abuse this function to set multiple slots at once unused. Shader module. Let's say mark unused. What you have to pass is a bit set. We are not the owner, and the first thing is then not used. So you can pass a null pointer here, and then we are not the owner. False. Is that correct? Current declaration can be printed as a null pointer, and if we are the owner is false, and this is not being used. So the only thing what I call here is this, which is really intended to just unset a single slot, but reset works for a whole bit set, so why not? And that must be called on the shader module. Where do I get the shader module? It's probably the owner of the declaration. Shader model, there, owner. So I think that now it works. If it compiles. X is the incomplete type. So now it is complete because I included the header. And so on. Just for the heck of it, let's write this to a file for a while. And then look at the file. And then find 167. And then see that now it got it right. Let me see. Module declaration. So we expect 4 declarations. 1, 2, 3, 4. Uniform buffer 1. Sorry, this is the second stage. It changed. The output changed. Yeah, okay. So apparently already in a previous pipeline something changed because of this, even though before it didn't assert. In that case, you cannot compare it anymore. So now you have beautiful output like this. Let me pick this one. So look at 1.2. No, that's not a nice one. Well, yeah, maybe use 2.2 could be used. Oh, still. So the first stage is 1 declaration which starts with 0. The second stage is 4 declarations which start with 0, 1, 2, 3. The third stage is 2 declarations which start with 0, 1, 2, and 1. All the slots within a given stage are different. 2.2, 1.1, 1.0, 2.0. Different from each other. And these two are also different. Finally, the auxiliary sources are also ordered. Texture 1, well, it's always ordered, just as a single declaration. These are 4, though they are always uniform buffer 0, 1, texture 0, texture 1. And this is also sorted. Uniform buffer comes before texture. However, progress of the week. 1.0 here is a slot that is already used here. And now contains the same data. Texture 0 here, texture 0 there. 7 here, 7 there. That is what is fixed. Now, for example, here we have 0.2 here, which is uniform buffer 1, 7, and also 0.2 here, which uniform buffer 1 and 7. But still the order is correct. Uniform buffer 1, texture 0, texture 1. Now here as well. So if you have 4 declarations, it must be uniform buffer 0, 1, texture 0, texture 1. Same here. And we have in total of 10 declarations here, so at least one must be a duplicate. And in this case, that is, I don't even see 0, 0 being used. Oh, here, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So everything is being used, and then 1, 2 is being used twice, which is then neatly at the third place for texture 0. And the count is also the same. I think it totally works. It totally works. Now yeah, of course you have to run it once at a higher speed. So let me write it to that file. Oh, what? What? Oh no. It stopped. What the? What? What? Oh no, failure. Oh fuck. Failure after 319,975 pipelines. Still a failure. Argh, and I thought it worked. Okay. Let me think. So I'm gonna do till minus n100 of the thing, then I should see it. And it prints a number pipeline stages. I could do grab that in that file, I guess. That's still a lot. Or not. What? The color gets in the way. Probably faster way to do it is no, not like that. I mean, I'm looking just for failures, probably a little bit faster. So let's do this. 100 is a bit much, but okay. And then I grab for Then we grab for what we were grabbing for, this. Yeah, nothing, grab, thank you very much. And then we do tail minus n2. So that prints that, and now I want to edit main.cpp and use a different seed. I'm just gonna try out some seeds, like one. You gotta be kidding me. That's impossible. Oh. It's not impossible. I forgot to run it. No, it's nice, smaller. Okay, maybe you can get it even smaller. Why not? Let's try to get it under 1000. So I'm gonna go back here. Try 2. And then we make it, and then we run it. And then we run that. That's pretty small. Why would I even try to make it smaller? Yeah, if I do this by hand, and this is going to take forever to get it smaller, right? It's probably small enough. Oh! Under one. Okay, we got really lucky. And that's like a chance of 1 in 300 that it happened. Okay, I'm going to stick at this one, so now it happens quick. Now I can turn on debug output again. Yeah, debug output on, right into screen, we can just do it. Amazing. And then we have to figure out why the hell it's failing. Let's see. So yeah, so pipeline 901 did go right, and then the next one fails. Why? I think I'm going to do the. I mean, none of my viewers is looking forward to me doing this again, right? So you don't mind that I stop, because I'm gonna go through it again, finding the next bug. But before I do that, I think I'm going to do the dishes. I have to do the dishes, and I have to cut up my my fruit and make breakfast, so that I can eat my breakfast before 1 p.m. Hi Zaz. Yeah, no, I have a. I should make pictures. Pictures. I have pictures, but I don't know. You know, conjuring up pictures is a dangerous thing. Waiting through my pictures. No. I have 3 monitors, and the one in the middle is, I think, one in the middle and the one on the right are 23 inch, I think. So it's BenQ BL. They don't sell it anymore. It's 24 inch, it says, I think, but I doubt it. BL 2411. If they still sold it, I would buy a third one, because my monitor on the left is a SyncMaster 205. So I have a BenQ BL Let's say 2411. Google doesn't even show it anymore. That's because I didn't type 11. So it's 24 inch, it's 1610. I like that. On the sorry, that's in Dutch. Why is this not saying this? Am I crazy? Oh, here it says. $1920 times 1200. So it's not super big for these standards, today's standards. I'm not saying that I tried out a lot of monitors and that this is the best option. Absolutely not. I think it's totally possible that a different monitor configuration would be more productive. I just don't know. So before this, monitors at some point became bigger and bigger and bigger and more, affordable. But I started with the power-hungry monitors that became really hot. Well, no, of course not. I started with CTR. I used to have the... how do you write that? Ilyama, something like that. Tell me. Oops. Ilyama monitor of 17 inch, I think. Or probably not even. No, CTR. A CTR monitor. It's really old. Vision Master. I don't know. Let me go to images. See if I can find it back. Yeah, this one. Yeah, this is the monitor that I started with. Well, not that's not true, of course. I mean, I've been coding for was it 46 years. So I've seen my share of monitors, but yeah, so it wasn't this one. But okay. This was the state of the art then. Really, it would even do in boom at the beginning to demagnetize itself. And I was sitting in front of this X-ray machine for many years. So waiting till I got a brain tumor, but it never happened. No, I think not that much X-ray came out of it. But yeah, it's probably better to these LCD screens still. I use this one. This is the monitor that I had. Yeah. So I had two of these monitors at some point. Really heavy. You can hardly lift them. Good old times. And then I switched. So my first LCDs after this were, and I still have one of them. Haha. That's a Sync Master 2OB-WB. You can still buy them? I don't think so. No way you can still buy them. It's a Tweakers. Yeah. I think this is a good picture. Yeah, totally. So I had 3 of these at some point. Yeah, but this thing is just smaller, right? It's not 23 inch. It's less. I don't know what 21 inch maybe. So the other monitor, the height of the other monitor that I just showed, it comes still here, something like that, like here. It's just a bit bigger. So it's next to this, and then it's like up all the way here. Then of course wider as well, maybe up till here. So yeah, I wish I could have 3 the same monitors. That would be just nice to have, I guess. And this one is consuming a lot more power as well, because it's old. Yeah, it's 1680 times 1050. 6 milliseconds. The price went up. How the is that possible? I think there was maybe after the market crash of 2008, and then they didn't have chips anymore or something like that. You cannot buy it anymore anyway. That was long ago. Yeah, getting old, man. Even that is a good old times thing, as it were. Samsung. I like BenQ. Unfortunately, I don't think BenQ anymore sells. Let me find that. Let's say I want buy a new monitor, and I want a BenQ again, and I want it to be 16 by 10. I think that's the main problem. No, I don't want overhead projectors. There's another IPS 1610, also 24-inch. With a really thin bezel, so you can put them next to each other. Well, maybe this one is pretty good. Would be a good replacement. It's the SW240. I still need to know the speed. I don't want to go over 5 milliseconds, I think. Where does it say that? The contrast ratio is a bit low. Okay, it's 5 milliseconds. No, this is a bit, I don't know, 1,000? Well, I set the brightness very low of my monitors, so I'm not sure if then this is influenced or not. Of course, I want my black to be really black, and that could be a problem. I don't know. Nobody knows what it is. 99%. Oh, that must be good. Of the what? The Adobe RGB color space. So yeah. Advertisement. I don't know what they're meaning there. Nobody knows. I want to find. The deal ends in 16 hours, so I'm not going to buy here because That's way too fast. I need to think about a new monitor for a week. Ridiculous psychological tricks. I hate them. So then, no, I'll pay more in a different shop than a shop that tries to trick me into. I mean, this is what scammers use. Oh, you have to do it fast. Not okay. Well, we're just looking at specs. There's more stuff like it. They have a lot of holy moly, man, that is expensive. Is it like whoa, that's so expensive. Also 1,000 to 1. It's maybe the same thing. Screen. $19 normally. Maximum energy use is 55 watts. Oh boy. Well, that's also quite a lot, I have to say. For if you have 3 monitors, it adds up. The monitors are like on all day. Yeah, I would rather have a monitor that uses 10 watts on a normal usage. Of this size. I don't know if that's possible. Or maybe this is when you have a pretty huge brightness. I'm not sure. My brightness is always very low, so. Why is it so expensive these days? I mean, I think I paid like less than 300 euros for my monitors. Yeah, I'm going to do this